let's talk about organic nomenclature. Now, if you're someone like Leo, you hate nomenclature, but you have to learn it. And guess what? With organic stuff, you get to learn an entirely new set of nomenclature. Now, let's think about organic and what it means. Organic means it has carbon. That's the thing that has the C in it. I hope you children know that. Nomenclature, naming stuff. So, naming stuff with carbon. Let's do it. Okay, the first thing we want to talk about is alkanes, alkenes, and alkynes. All of these are hydrocarbons. In case you can't pick up on that, these have hydrogen and carbon. Alkanes have single bonds between the hydrogen and the carbon, or the carbon and the carbon. Alkenes have double bonds, and alkynes have triple bonds. Now, a handy way to remember this is that they're in alphabetical order. So let's look at some of each. Let's take an alkane. Methane. C, H, 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 H. Single bonds, all single bonds. Because there's one carbon, that makes it methyl something. And because it's an alkane, that makes it something ane. So you get methane. Another alkane would be H, 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 add some more single bonds, ethane. Because there are two carbons, it's ethyl something or other, and because it's an alkane, it's something ane. So what about alkenes and alkynes? An alkene could be that. We've made it a double bond, and that makes it an alkene. You've got two carbons, and that means that it's ethyl something, so this is ethene. Finally, let's look at alkynes. Triple bonds. Get rid of that, and triple bond. That is ethene, or ethine. Triple bonds, two carbons, have a ball. Okay, next thing is alcohols. These have OH tacked on to the end of the chain, or actually anywhere in the chain, instead of just the H that you had before. So we could look at methanol, or methyl alcohol. That would be C, H, 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 and instead of an H here like we had in methane, it's going to be OH. See? It's got the OH. That makes it an alcohol. Okay, next is ketones. These have C double bonded to O somewhere in the middle. So you could have C, 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 O there, H, H, and hopefully I can save time in the future by not writing in all of these H's and you can just know about them. But this right here, this is a ketone. This is acetone. Because it's got the C double bonded to the O between two carbons. Good. After that, you've got aldehydes. Those would be something along the lines of C, C, O. Okay, that works. These have the C double bonded to the O like the ketones, but now it's on the end instead of in the middle. So this would be acetyl or acetaldehyde, something like that. Do what you will with it. Enjoy. Alright, and the last thing is acids. Don't judge me for the way I write my words. Acids, they've got this COOH thing in it.
Carboxyl group.
Thank you, Amy. Yes, it's a carboxyl group. Call it what you will. I don't want to make this too complicated for them. That's what I thought. Anyways, now that we've taken care of her, here's some fancy acidy stuff. You've got your C, connected to your C, connected to your C, connected to your COOH, and these are all hydrogens. It's a weirdly named acid, and I really don't think you guys need to bother with the names, because Mr. Twong loves you. He's not going to make you mess with the weird names that these acids have. Now, if it's that, then you've got something else. If you've got that, it's another acid. It's just such a party with acids, isn't it? Good. Alright, children, I don't want to bore you with all of the ins and outs of the complex namery associated with organical nomenclaturisms, but I think you guys should know some of the basics. So look at this chart. You've got the number of carbons in your molecule and the prefix associated with that number of carbons. If you've got one carbon, then the prefix is methyl. That gives you names like methane and methene and methanol. If you've got two, then that's ethyl. So you get ethene and ethanol. 3 carbons is propyl, propane. 4 is butyl, butane. And after that, you start to see a pattern. 5 is pentyl, 6 is hexyl, 7 heptyl, 8 octyl, and so on. If you can't see that pattern, this video, you shouldn't even be watching it. You've got bigger problems. But this is how you're going to name stuff. You're going to use the prefix and then the other part of the name, which we showed you earlier. And that's really the basic idea. So let's give it to Amy so she can teach you about combustion.
Combustion! Alright, what is combustion? Combustion is the reaction of a substance with oxygen. And usually the products are this substance, it's their oxide. So, as you see, I've written out some combustion reactions. This is the combustion of copper sulfide, and this is the combustion of carbon sulfide. I think that's how you say it. So, one thing to note is that whenever there is carbon in a reaction, carbon dioxide will always be a product. And another thing to note is that if you have something as a reactant in a combustion reactant, the oxide of that same thing will be in a higher valence state or oxidation number in the oxide, which is kind of interesting. Another thing about combustion that's pretty important is that if you have a hydrocarbon, which I believe Arya explained are things with hydrogen and carbon, then the products will always be CO2 and H2O. And interestingly enough, there's an equation you can use to show you the moles of the reaction. Okay, so this is the reaction, and this only applies to the combustion of hydrocarbons. So this is your hydrocarbon with a certain number of carbon, X, certain number of hydrogen, Y, and this is the equation to show you, to just work everything out and show you what all the numbers are.